Hey guys, so today we're going to be doing our second lesson of chapter 9. So the goals for today are to learn how to do chord calculations, and we're going to start with a couple definitions. Okay, so we already talked about what a chord is yesterday, but just a reminder, it is a straight line that goes across a circle, so it has 2 points on the edge of the circle. Perpendicular lines are lines that meet at 90 degrees. And the one term that might be new to you is a bisecting line, which is a line that cuts something directly in half. So if you have a line that bisects a chord, that bisecting line is going to go right through the middle of the chord. And if the bisecting line also hits the middle of the circle, that means it will be perpendicular to the chord. So in this example here, I've got my chord that goes across the circle from one point on the edge to another. This is the center of my circle right here. And then I've got this bisecting line that goes from the edge to the center. What that means is that each half of this red line, each half of this chord are the same length since it's being bisected directly in half. It also means that this green line here, my bisecting line, and the chord are meeting at 90 degrees. So all of these angles in here are 90-degree angles. It also means that that bisecting line is a radius in this case, because a radius is any line that goes from the center of the circle to the edge of the circle, which is what that bisecting line is doing. However, when we are doing chord calculations, we need to have a chord, obviously. We also need to have a bisecting line, but then we also need to draw in a radius from the center of the circle to one of the edges of the chord. So like this, for instance, in order to make a right triangle. I could have also gone from the center to this edge of the chord. Doesn't matter which way you go, as long as you're going from the center to the edge of the chord. That is also a radius because it's going from the center of the circle to the edge of the circle. So right now, I've got a radius here that I've just drawn in, and my bisecting line is also a radius. And this is how we always need to start with our chord calculations, is with a bisecting line, a chord, and then another radius drawn in order to make a little right triangle. Okay, so in this example, I have said that a circle has a diameter of 10 centimeters and a chord length of 8. What is the maximum distance between the chord and the bottom of the circle? And then in this diagram here, we have a chord that's going across the circle right here, and a bisecting line as well. So of course, we have to start by drawing in a radius. So our very first step here is going to be to take our 10 centimeter diameter and divide it by 2 in order to get our radius. So our radius is going to be 5 centimeters, which I can draw in from the center to either edge of the chord to make a right triangle. So when I do that, that is now 5 centimeters. I also know that this bisecting line is 5 centimeters. However, the entire bisecting line is not part of this right triangle. So I don't know what portion of it is above the chord here. So I actually don't know what this side length is right here of my right triangle, but I do know what the bottom is, because if my entire chord is 8 centimeters, this half of the chord must be 4, since it is bisected and cut completely in half. And so what that means is I now have a right triangle where I know 2 of the side lengths. I'm going to find the other side length, which I will call A, since we're going to be using Pythagorean theorem. I could call it B as well. It's definitely not C because C is always across from the right angle. So that'll be our next step. Step number 2. A squared plus B squared equals C squared. We can always use when we have a right triangle and we're missing a side. So A squared plus 4 squared equals 5 squared. In order to get the A squared by itself, I'm going to move the 4 squared to the other side. Because it is a positive 4 squared, I will subtract 4 squared. That leaves me with A squared equals 5 squared minus 4 squared is 9. And then, of course, in order to get rid of the squared sign and get the A totally by itself, I need to square root it. And what I do to one side, I must do to the other. And then the square root of 9 is 3. So that tells me that this upper portion of my bisecting line is 3, but it's asking how far is the chord from the bottom. So what it's asking for is actually this distance right here, not the distance that I just found. So this is where the last step comes in. You know that the radius, which is this entire bisecting line here, is 5 centimeters. So if this entire line is 5 centimeters and the uppermost part is 3 centimeters, I just do 5 minus 3 gives me 2, and that must be the remaining part on the bottom. Again, the whole thing is 5. I subtract the top part, that gives me the part on the bottom. So that is my final answer. It is 2 centimeters away from the bottom. A really common mistake is to get this 3 and then think that the bisecting line is also cut in half by the chord. So people think that the top of that line and the bottom are the same and they just multiply it by 2. You cannot do that. You always, if you're finding part of a bisecting line, you always need to use the radius, okay? Use the radius, okay? Don't just multiply it by 2. Okay, let's try another practice question. Okay, in this next example, I have told you that the chord length is 12 centimeters, so this would be the chord that goes from one edge of the circle to the other. I've also drawn in this little line right here and said that it's 8 centimeters. And what I would like you to solve for is that entire line length, so right here. Okay, so the first step is, of course, to draw in our radius from the center to the edge of the chord to make a right triangle. And that radius, I know, is 8 centimeters because this line that I've drawn in over here also goes from the center to the edge, which means it is a radius. It was just drawn in a place that wasn't useful to me. So that is my 8 centimeter radius. I also know that this entire chord is 12 centimeters, which means this half of my chord must be 6 centimeters. And once again, I'm solving for the side of my triangle. It's not always going to be the side that I'm solving for, but in this case, I need to find A. So once again, I'm going to start with Pythagorean theorem. So A squared plus B squared equals C squared. I will plug in my 6. My 8 is my hypotenuse, so it has to go where the C is. Then I'm going to move the 6 squared to the other side by subtracting it. 8 squared minus 6 squared is 28. And then, of course, I need to square root it to figure out what just A is. And that is 5.29. So I figured out what just the bottom part of this line is, but I want the entire line all the way to the top. Common mistake people would make is to just multiply this by 2. However, that would not be correct. What you need to realize is that the top part of this line goes from the center to the edge of the circle and is therefore a radius. So my last step is just to take my 5.29 and add the radius, which is 13.29. That is my x value that I was looking for, so that would be my final answer. Again, you must use the radius. Okay, that's it for the calculations. The one other thing I want to go over is how to use bisecting lines to find the middle of your circle. Okay, so if you are trying to find the center of a circle, the first step is to draw 2 non-parallel chords. So if this was my circle, I might draw one chord like that, and another chord like that. They're not parallel to each other. Other than that, I can draw them wherever I want. Then I'm going to draw the bisecting line for each of them, which is a line that is going to cut them in half and hit the chord at 90 degrees. So if I'm looking at this red line here, I'm just going to rotate it a little bit so I can kind of see roughly where the middle of that is and make sure that I'm hitting it at roughly 90 degrees. And just draw a bisecting line through it. Then I'm going to do the same thing with my other line here. I'm going to cut it in half, make sure I'm hitting it at 90 degrees, and just go straight through it. And then wherever those bisecting lines meet, that is the center of my circle. Obviously, if you have a ruler, that would be ideal, so you can actually measure, to make sure that you're cutting your chord in half, but it's fine if you just eyeball it as well. The one other thing that you may need to have to do with some of these calculations is draw your own diagram. So you're not always going to be given a diagram to go with the chord problem that you're dealing with. So I think we'll do one more example just to go over how that would look. Okay, so if you're not given a diagram, drawing a diagram should be the very first step in both chord property problems, which is what we're doing today, and tangent properties, which is what we're going to be working on next. So in this example, I've said a circle has a chord of 16 centimeters. A line bisects the chord 4 centimeters from the center of the circle. What is the diameter of the circle? So obviously we'll start by drawing a circle. That's my center. Then I'm going to draw my chord. And it doesn't matter where you draw the chord as long as it doesn't go through the middle of the circle. Other than that, you can draw it wherever you want. I'm just going to draw it across the bottom, but you could draw it on a diagonal, you could draw it at the top, wherever you want. Then I'm going to draw a bisecting line. So that's going to go from the center of the circle and cut my chord in half at a 90-degree angle. So like that. And then I'm just going to label some things. So I know my chord is 16 centimeters, which means that either half of my chord is going to be 8 centimeters. And then it says the line bisects the chord 4 centimeters from the center. So this is my bisecting line. It is hitting the chord 4 centimeters from the center, which means that is 4. And then of course, as always, I need to draw in a radius that goes from the center to one of the edges of my chord so that I have a nice 90-degree triangle, a right triangle. And so this time, I'm going to be looking for my C value because it is my hypotenuse that is missing from my triangle. So A squared plus B squared equals C squared. Plug in my 8 and my 4 in either the A or the B spot. Then I'm just going to solve 4 squared plus 8 squared, plug it in all at once. That gives me 80 is equal to C squared. And then I will square root. And I get 8.9 as my C value. I'm almost done, but because it wants the diameter, I just need to take my radius and times it by 2. So the 8.9 is 17.88. I'm going to round it to 17.9. And that's my final answer. Okay, I hope you enjoyed.